Hello! I bet you were super disappointed when I wasn't in class today, but don't worry, I'm here and you guys get to learn stuff in probably the most awkward way possible. Sorry. So let's start out today's lesson on limiting reactants, doing a simple stoichiometry with sandwiches. I love a good grilled cheese sandwich. Sharpie, what do I actually need to make a grilled cheese sandwich? If you said 2 pieces of bread, 1 piece of cheese makes 1 sandwich, you're correct. Way to go. So now what if I have 24 slices of bread and 7 pieces of cheese? Starvin, how many sandwiches can I actually make? Awesome, you can only make 7 sandwiches. So if we think about why you can only make 7 sandwiches, well, it's because I'm going to run out of one of my ingredients for my sandwiches before the other. Gio, which will I run out of first, the bread or the cheese? Very good. You're going to run out of the cheese first. So then I can actually go backwards then and calculate, well, how much bread did I use and how much bread do I have left over? Holly, how much bread will I have left over? Awesome, 10 slices. Take a few seconds right now and explain to the rest of the class how you got the answer of 10. I'll wait here. Okay, very good. If you've got 24 slices of bread to begin with and you use 14 slices to make your 7 sandwiches, you've got 10 left over. Keep up the great work, guys. You're doing awesome. So now, if we think of this in terms of chemistry, we've got limiting reactants. These are the reactants in a chemical reaction that are going to limit the amount of product that can be formed. Basically, when all of this reactant gets used up, the reaction's going to stop because there's no more starting materials left. So if we think back to our sandwiches, Peyton, which of my ingredients, the bread or the cheese, was limiting? Very good, the cheese. It got used up first. So we would say that the cheese is our limiting reactant, which means that our bread is our excess reactant. This is the reactant in a chemical reaction that's going to remain after all of the limiting reactant has been used up. We have extra left over in the end. So what we want to do now is actually learn how to solve problems related with limiting reactants. And these are a little different than the stoich problems we've learned about in the past because, as you can see, we're given 2 pieces of information. We're given the moles of one of our reactants and the moles of our other reactant. So we're going to go through 4 basic steps to help us to solve these limiting problems. So let's take a look at our example. I've got quartz, which is silicon dioxide, SiO2, and it's going to react with hydrogen fluoride gas to produce silicon tetrafluoride gas and liquid water. So here's my reaction at the bottom, and it says that I start with 4.5 moles of the silicon dioxide and 2.0 moles of hydrogen fluoride. The very first thing we need to do is go through and balance our equation. So if I look at the silicones, I've got 1 on the left, 1 on the right. I've got 2 oxygens on the left, but I only have 1 on the right, so I'm going to put a 2 in front. That tells me then I have 4 hydrogens, so I need 4 hydrogens. Now I have 4 fluorines, but I've got 4 fluorines on the other side. So there's our balanced equation. And so now the first thing we need to do is step 1, determining what we have in moles. So I'm going to write down what I have. And this problem's really easy because it just told me what I have right away. Not all of our problems are going to do that. So I start with 4.5 moles of the silicon dioxide, and I start with 2.0 moles of the hydrogen fluoride. So I write down what I have. And then I'm ready to move on to step 2. In step 2, I'm going to pick one of the reactants and determine how much of the other reactant I'm going to need using stoich. So I'm going to pick my silicon dioxide. If I have 4.5 moles of silicon dioxide, how many moles of hydrogen fluoride will I need to react? Well, I'm just going to do a simple mole-to-mole problem. So 4.5 moles of silicon dioxide. Are you writing this down? You should be writing this down. And now I'm going to right away use our mole ratio. I've got a 1:4 mole ratio based on my balanced equation. Oops, that's not right. SiO2. Gotta watch me, guys. And I've got 4 moles of my hydrogen fluoride. And so when I do the math, I find out that I am needing 18 moles of hydrogen fluoride to react with 4.5 moles of silicon dioxide. So in step 3, I'm going to compare what I have available to me with what I need. And if I have more than I need, well, then I'm going to have extra left over in the end. But if I need more than I have, my bad, if I don't have enough, well, then that's what's going to be limiting, like our cheese. I didn't have enough cheese. So now I have 2.0 moles of hydrogen fluoride. The problem told me that. And I just calculated that I need 18 moles. Well, in this case, I have less moles than I need. So my hydrogen fluoride is limiting. It's like my cheese. I ran out of it before I was able to finish the reaction. And then I have extra silicon dioxide, which was like my bread. Our final step is to answer any additional questions that might be given to you by the problem. A lot of times the problem will ask you, well, how many moles of product can actually be produced? Well, in order to figure out how much of this I can make and how much of this I can make, I have to use what is limiting. Okay? I know that silicon dioxide is excess. I'm going to have extra left over. So the amount of product is going to be determined only by our limiting reactant. So you're going to go through and solve using your mole ratios. So 2.0 moles of hydrogen fluoride. And now I want to convert it, figure out, well, how many moles of silicon tetrafluoride can I make? Well, I've got 4 moles of hydrogen fluoride for every 1 mole of silicon tetrafluoride. And when I do that division, after my units cancel, I would make 0.05 moles of SiF4. Make sense? I'm going to do the same thing comparing the hydrogen fluoride to the water. So again, I start with the limiting amount, 2.0 moles of hydrogen fluoride, according to, that was a squiggly line, sorry about that. According to the balanced equation, I've got 4 moles of hydrogen fluoride for every 2 moles of water. And when I do that math, I figure out that, well, I can make 1 mole of water based on the amount that I have available to me. Just like if I have 7 pieces of cheese, I can only make 7 sandwiches. Ugh, math is hard, you guys. All right, so another additional question might ask you about moles of excess reactant, how much is left over. So when I asked you before how many slices of bread we have left over, that's the same kind of question. So again, we're going to start with what limits, the hydrogen fluoride limits, and I'm just going to compare it to, well, how many moles of silicon dioxide are going to actually react. So I'm going to take 2.0 moles of my hydrogen fluoride. I'm going to use the mole ratio. There's a 4 moles of hydrogen fluoride for every 1 mole of silicon dioxide. And what that means is that I actually use 0.5 moles of silicon dioxide. But I started with 4.5. So I subtract the amount that I use, and that gives me the amount that's left over. So let's kind of look at this big picture. So remember, the first thing I needed to do was first figure out how many moles of each reactant I have. And in this case, the problem told me. I didn't have to do any calculations. Then I'm going to pick one of the reactants. In this case, I just picked silicon dioxide. I could have also picked hydrogen fluoride. You'd get the same answers. So I'm going to use stoich and the mole ratio to figure out how many moles of hydrogen fluoride I actually need. And then I compare how many moles of hydrogen fluoride I actually have to how many I actually need. And I notice that I don't have enough. That means that hydrogen fluoride is going to limit the amount of product that I can make. So then I can use the mole ratio again for each of the products to figure out how much I create. So with a 4:1 mole ratio for the silicone tetrafluoride, I can make 0.5 moles of that silicone tetrafluoride. With our hydrogen fluoride in our water, it's a 2:4 ratio, and so I can actually make 1 mole of water using our 2 moles of hydrogen fluoride. Then I need to go back and figure out, well, how much silicone dioxide do I have left over? So I again use my mole ratio and some simple stoich to find out that, well, I've used 0.5 moles, subtract it from my original amount. That tells me how much I actually have left over. I hope this was helpful. And so what I want you to do now, there are 4 questions in your packet that are just like this example we went through. I want you to go through those 4 examples, take about 10 to 15 minutes, go through all the steps. If you've got questions, the substitute has the key so you can check your work and get working on that. In about 10 to 15 minutes, you're going to watch part 2 of this amazing podcast. I know you're really enjoying it, to learn how to do this process using grams. All right, see you soon.